Sorry, I was mistakenly pressed the stop recording button and it will stop the video. And let's continue on the example. So that with this set, so in this lecture we are going to have in total 5 video parts, okay, instead of 4, as I mentioned in the first video. Okay, so let's move on. What is the formulas for the moments of the links? So it's equals to NII plus PC1II cross products FII, and then plus PI plus 1I cross products the rotation matrix I plus 1 Fi plus 1I plus 1. Okay, good. So let's go back to here. So now we can do the inertia for the second link will be equals to, so in this case I is equals to 2. So it will be equals to the capital N22 okay, plus rotation matrix is R 2 3 and N33 plus PC22 cross product capital F22, okay, and then plus P23 cross product rotation matrix times F33. Okay, so this simple because you can see the first term is equals to 0, second term is equals to 0 because the moments of the tip points N33 is coming from here, right? Is equals to 0. Okay, and F33 is also equals to 0. The last term equals to 0. It's only leaving PC22 cross products F22, and F22 is given here. So let's see what is PC22. PC22 is equals to L200, right, along the x-axis. Cross product F22. So this guy cross product this guy, it will be equals to, ignore the first row and then do the cross products. So let me just give you the final results here. It will be equals to 0, 0, and M2 L1 L2 C2 theta 1 double dot plus M2 L1 L2 S2 theta 1 dot square, and then plus M2 L2 square theta 1 double dot plus theta 2 double dot. Okay, good. So this is for the N22. So after we have the N22 and F22, so the next step is to figure out what is F11, how much force you need to be generated from the motors of the first link. Is F11 equals to R12 F22, right, plus F11. Okay, so in this case it would be equals to, so the rotation matrix R12 from the kinematics information will be equals to C2 negative S2 C2 0 0 0 0 1 times F22. F22 would be capital F22. It will be this guy. Okay, and then plus capital F11. What is capital F11 coming from? Coming from here, right? So this will be the capital F11. And then you can, okay, multiply all these matrix and vectors together and summing up together. I will try to ignore the results here first and I'll give you the final results later. Okay, so after that, we can also calculate what is N11, right, by following these equations. Okay, so N11 in this case will be equals to N11 plus R12 N22 plus PC11 cross products capital F11 plus P12 cross product R12 F small f 22. Okay, so then what is N11? Capital N11. Capital N11 is coming from here is equals to 0. So this term will be equals to 0. Small n22 will be this guy. And the rotation matrix will be the same as this one. And what is PC11? It will be L100. Cross product F capital F11, it will be this vector, right? This vectors here. Okay, and PC12 would be which one? It would be L100. It would be the same as the PC11. P21 will be the same as the PC11. The reason is that the mass of the center of the mass is coincident with the tip points of the first link. Okay, and also rotation matrix R12 is unknown, and F22 is also unknown informations from here, right? Is equals to capital F22. Okay, and then you can again summarize everything together. Okay, and after you calculate F11 and N11. Okay, so what is the next step? The next step is you can calculate what is the torque you need to generate from the first link. It will be equals to, okay, so this requires us to apply the last equations here. Okay, is tau equals to the inertia vector along the z-axis. Okay, so they will be just simply the last elements of the N11. Okay, so it will be N11 transpose 001. Okay, and let me give you the final results here. So it would be equals to M2L2 square times theta 1 double dot plus theta 2 double dot. Okay, and then plus M2 L1 L2 C2 2 theta 1 double dot plus theta 2 double dot. Okay, and then plus M1 plus M2 L1 square theta 1 double dot minus M2 L1 L2 as 2 theta 2 dot square, and then minus 2 M2 L1 L2s 2 theta 1 dot theta 2 dot. Okay, so this is for the torque. So this is how much torque you need to generate from the motor 1 in order to have the low-body manipulators to follow the desired trajectories. Okay, and torque 2 is equals to, let me also just give you the final results here. It will be equals to M2 L1 L2 C2 theta 1 double dot plus M2 L1 L2 S2 theta 1 dot square, and then plus M2 L2 square theta 1 double dot plus theta 2 double dot. Okay, so this is the dynamics. So up to this point we have established the dynamics of this second link low-body manipulator, two-link low-body manipulator. So as you can see that the whole procedure so far involve a lot of calculations and iterations, right, including the outward iteration, where you need to apply the first set of equations twice, right, for these two-link manipulators to obtain all the acceleration information for the center of the mass. Okay, and after that, you also need to go through another iterations. It's called the inverse iterations, right, to obtain, right, to apply the second set of equations here also for twice. And finally, you can find out what is the torque tau 1 tau 2 you need to generate, okay, for this problem. Okay, so then you can see that to solve this problem, the final results would be these two equations. Okay, of course tau 2 is obtained by doing n2 transpose 0, 0, 1. Okay, so 0, 0 is the z11 axis. This would be the z22 axis. Okay, so in the next video I will show you some new materials, okay, including how we are going to rewrite this dynamics formula, dynamics results. You can see here it's a little bit messy over here, but we are going to figure out another compact way to reformulate these dynamics expressions. And also I will talk about the second methods of Lagrangian formulations of the dynamics, right? So instead of using this very tedious and complicated iteration procedures, we are going to learn another methods based on the energy balance methods, how we are going to derive the dynamics, exactly the same dynamics, right, by following a much similar procedures. Okay.